This chapter introduced the fundamental building blocks of matter: atom, smaller unit of an element made of protons, neutron, electron. Molecule or two more atoms chemically bonded like O2 or H2O. And ions, atoms or molecules with a net positive or negative charge from losing or gaining electrons like Na plus or Cl minus. Chemical equations use symbols and numbers to represent these substances, showing how atoms rearrange in a chemical reaction reactant right arrow product while conserving mass. Pure substances divided into two, which is elements and compounds. Elements also divided by two, which is atoms and molecules. Example for atoms is Ne and example for molecules is O2. Compounds also divided into two, which is molecules and ions. Example for molecules is ClO2 and example for ion is NaCl. Atoms are the smallest particle of an element that retains the characteristics properties of the element. Atoms are made up of three subatomic particles, namely proton, neutrons, and electrons. Protons and neutrons is the center of an atom, which is nucleus. As we can see on atom structure, nucleus are the center of an atom, contains protons and neutrons. Protons and neutrons are in the center of the atom, making up the nucleus. Protons have a positive charge, while neutrons have no charge. Electrons move around the nucleus in circular. Electrons have a negative charge. Molecules is a structure consists two or more atoms that are chemically bound together and thus behave as an independent unit. Each is also combined in specific ratios to one another. An ion is an atom or group of atoms that have a net positive or negative charge. In any given atom, the number of protons is always equal to the number of electrons. Neutral atoms can lose or gain electrons and become charged. The charged atoms are known as ions. This is a type of ions. Cation is an ion with a positive charge. If a neutral atom loses or one or more electrons, it will becomes a cation. Anion is an ion of negative charge. If a neutral atom gains or more electrons, it becomes an anion. This is a step for chemical formula. Firstly, write the symbol for the metal cation and its change. Secondly, write the symbol for the non-metal anion and its charge. Thirdly, charge without sign becomes subscript for other ion. 4. Reduce subscripts to smaller whole number ratio. And the last one, check the sum of the charge of the cation cancels the sum of the anions. Name the first element in the compound, the metal, by its actual name. The second element is then named by using the base of the nonmetal's name and ending IDE. For transition metal to nonmetal, name the first element in the compound, the metal, by its actual name. Then you must also include its oxidation number by putting it bracket after the name. The second element is then named by using the base of the nonmetal's name by adding IDE. For nonmetal to nonmetal, name the first element to the left side on periodic table. Then name the second element by ending it with IDE. The Greek prefix are used to tell how many of each nonmetal ion are present in the compound. If there is only one of the first element, then the prefix mono is omitted. Metal to polyatomic anion. Positive charge species on left using stop method or common name. Negative charge species on right using name of polyatomic ion. Use parentheses as needed. For example, BaSO4, the name is barium sulfate. Naming hydro acids. Hydro plus halogen name plus IC. Acid which not contain oxygen are named by adding the hydro prefix to the root name of the element, followed by the IC suffix. For example, HF. The acid name will be hydrofluoric acid. Naming oxo acids. Oxo acid is an acid that contains hydrogen, oxygen and another element. For example, HNO3. The name is nitric acid.
Hi everyone, I will be presenting the mole concept and Avogadro. So, in chemistry, atoms and molecules are so small that they are impossible to count individually to bridge the gap between the microscopic worlds, which is atoms, and the macroscopic world, which is grams, and we use the mole concepts. So, what is a mole? So think of a mole just like the word dozens. So one dozen equal 20 items like eggs or donuts, while one mole equals 6.022 times 10 power of 23. So this is specific number 6.022 times 10 power of 23 is known as Avogadro number, which is we use symbol of Na. It is an incredibly large number because atoms are incredibly small. For perspective, one mole of marbles would cover the entire Earth to a depth of several miles. The beauty of a mole is that it releases a substance atomic mass to its wake in grams. One atomic mass, one atoms of carbon-20 weigh exactly 20 mu. This means that if you look at the periodic table, the atomic weight of any element is also a smaller mass in gram per mole. So today I want uh, I want to talk about to solve chemistry problems. So you usually need to convert between mass, moles, and numbers of particles. So to find out how many moles are in a certain weight of the substance, number of moles equal mass divided by molar mass. While to find out how many individual atoms or molecules are in a sample, number of particles equal moles times Avogadro number, which is 6.022 times 10 power of 23. Next is percent composition of atoms, and the formula is the percent of the composition is N times M's element divided by M compound times 100%. So to find this, we first look at the chemical identity of the substance. We determine the weight of every single atoms present and add them all together to find the total mass. Then we take the weight of one specific element and see the what fraction it represents of that total by converting this fraction into percentage. So we get the clear picture of the distribution. This information is vital for the scientists because it allows them to verify the purity of a substance. If the percentages do not match that what is expected, they know the sample might be contaminated or is a different substance entirely. It is the bridge between the invisible world of atoms and the measurable world of mass that we can observe in a laboratory.
The first step to balancing the chemical equation is to write the correct formula for the reactant on the left side and the correct formula of the product on the right side of the equations. Next, change the number in front of the formula, which is the coefficient, to make the number of atoms of each element the same on the both sides of the equation. Do not change the subscript. After that, start by balancing those elements that appear in only one reactant and one product. Finally, check to make sure that you have the same type of atom on the both sides of the equation. This is an example of the balancing chemical equation, which is titanium dioxide plus bromine trifluoride equal to titanium tetrafluoride plus bromine plus oxide. To solve the equation, we assume that A is 1 and C is 1 too, which means 2A equal to 2E, and we change the A into 1, which means E equal to 1. Then 3B equal to 4C. We already know that C is 1 too, which means B equal to 4 per 3. Finally, 2D equal to B, and B is a 4 per 3, which means that D is equal to 4 over 6, and we can simplify it as a 2 per 3. Hence, we can write the equation as the given. The first thing to know about stoichiometric calculation is that it is the quantitative relationship between the reactant and product. In chemical equation, the formula reactant are written on the left side of the equation and the formula of the product on the right side. Coefficient equal to number of moles. Finally, the coefficient in a balanced chemical equation indicate both relative number of molecules or formula units in the reaction and the relative number of moles. First, we must write balanced chemical equation. Next, convert quantities of known substance into moles. Then, use coefficient in balanced equation to calculate the number of moles of the salt quantity. Finally, convert moles of salt quantity into desired unit. This is an example of the stoichiometric calculation. There's two ways to calculate stoichiometric calculation, which is this one, which is the normal one, and we got the table calculation, which is a little bit more easier. Limiting reactant is a reactant in a chemical reaction that limits the amount of product that can be formed entirely consumed during a chemical reaction. Excess region is a reactant in a chemical reaction that remains when the reaction stops. When the limiting reactant is completely consumed, the excess reactant remains because there is nothing with which it can react. This is an example of limiting reactant equation, where there is I, C, and F. I mean for initial, C for change, and F is for final. For the initial, we must find the mass and the mole of the molecules. For C, we must find the molar ratio and the mass. Lastly, for the final, we must find the mass of I minus C and find the mole. Theoretical yield is the amount of product that will be result if all the limiting reaction react. Actual yield is the amount of product actually obtained from a reaction. The formula of percentage yield is equal to actual yield over theoretical yield multiplied by 100%. This is an example of a reaction yield question. In a lab experiment, 0.8 gram of copper metal should be produced. If a student actually makes 0.77 gram of copper, what is the percent yield? First, we must use percent yield formula, which is actual yield over theoretical yield multiplied by 100. Then, we put those numbers, which is 0.77 gram over 0.8 gram multiplied by 100. And then, we sum up and get 96.25%. Finally, molarity is the concentration of a solution expressed as mole of solute per liter of a solution. Its units is mole L minus 1, or simply written as M.